So, again, working with Unit 4, which is dealing with probability and basic probability ideas, we're going to go to Section 2, which is events. So, we're going to delve more. We defined an event in the previous lesson as this is the outcome, that specific outcome we are looking for when we do an experiment. And we're going to use boolean operators to combine events, which is something that you might not be familiar with the word boolean, but you've used these before. It's basically what you use for, say, Google searches and such. So, again, we have this probability. Probability of event is F over N, when F is the total number of ways that event can happen, and N is the size of the sample space, or the total number of different outcomes you can get. But let's look at the event some more. Before we do that, we're going to talk about the sample space. Again, I used that already. The sample space is the list of all the possible outcomes. Again, when we're using that F over N, we need to have equal likelihood of any possible output happening. So as we looked at when we were rolling the two dice in the previous lesson, we couldn't just say, hey, the sum of the two dice. We can't use that as our sample space, as our events, because it's not equally likely that you would roll a 7 or you would roll a 12. So we have to make sure that every single option is equally likely to use that formula, that F over N. So one way we do it is basically list everything that can happen. So we're going to look at a few of these, looking at a deck of 52 playing cards. So I just have them listed out for you here. We have our 4 suits: hearts, diamonds, clubs, and spades. And we have our values ace through 10, jack, queen, king. So this is a sample space for picking a card at random from a deck of cards. We have an equal likelihood that we would pick any one of those 52 cards. So we can use this. So now we look at using that as our sample space. We look at what some events could be. So for example, if my event is the card is a jack of diamonds, there is only one possible outcome in my sample space that would give me the event I wanted, the jack of diamonds. So that would be my event. So my F value would be 1. If my event is the card is a jack, now there are 4 jacks in my sample space. So there are 4 possible outcomes that would give me this event of the card is a jack. The card is a diamond. Again, we look at that. We pick out all the diamonds from our sample space. There are 13 possible outcomes. So if this is my event, I have 13 outcomes that would be favorable for this event. Card is a face card. We got those. We got the 12 there. So these would be the events we're talking about here with this deck of cards. So that's pretty much straightforward. You're saying, hey, we don't need to spend time with this, Mr. Wilkin. We got it, right? Okay, so we're going to look at, though, combinations and variations. So we're going to be playing with the Venn diagrams to help us think about this. So again, our Venn diagram, we start with a box. We call that the universe. It's everything. And inside the box, we say, here's what's important. So in this case, and always, the universe, the box, is my sample space. This is every possible outcome. A, what this green circle here is showing me, what are all the possible events in that sample space that would satisfy event A. Now, the first thing we're going to talk about is the complement, or the not. Complement of an event are all of the outcomes that are not in the event, which is why we call it not A. You can also think about, say, complementary angles from geometry. The idea is you have two angles add up to a line, add up to 180 degrees. They're complementary angles. The complement of an angle is whatever's left over to make it up to a line. It's whatever's not in that angle. So we use that. We often say not A. So this would be our Venn diagram. So our sample space, and you notice we didn't shade inside the circle, we shaded outside, because we want everything that's not in our sample space, or sorry, not in our event. So multiple events, we're dealing with and or, intersection, the union. I didn't want to get to that yet. Let me go back. I'm trying to go here. Kind of to keep them straight. I'll go into a little bit more detail, but I'm going to go back to my good old pizza because I like pizza, right? Okay, when I think about and or, the differences between them. If I go out to eat pizza, I'm going to order pizza. I want sausage and pepperoni. I need both of them. If these are my events, I need the sausage event to be true and the pepperoni event to be true. I'm not happy if it's just pepperoni. I'm not happy if it's just sausage. I want them both. And when we're doing and, we have to have both of those true. But, when it comes around to it is, I'm okay with original crust or stuffed crust. When I get to what crust do I want on the pizza, I'm not that picky. I want one of those two. I don't want super thin. I don't want super thick. I don't want any of the other weird things. So if it's original, I'm good. It doesn't have to be stuffed, but if it's stuffed, I'm good. It doesn't have to be original. Either or. So when you're thinking about and or, think about how you would order a pizza. What are your preferences? That kind of helps me keep straight when I'm trying to think which is which. So let's go back to, here we go. So we call the and the intersection. It's kind of like the intersection on, when I think about intersection, I think about, we have the intersection between two roads. The intersection here is the point that's on the north-south road and on the east-west road. It's on both roads. That's what we mean by the intersection. So the intersection events that A and B or outcomes belong to both A and to B. So we use the word and sometimes. We use the and symbol. Or this is a symbol from set theory. We use it. It's kind of like, I kind of think about it as a kind of an A without the little line through it. But that's the symbol that we use to mean and. And when we use this, again, we want the intersection. We need both events to be true. So our Venn diagram is going to look like this. So here's event A, here's event B. We only want where they overlap, where they intersect. Where you're in event A and you're in event B. But here you're not in A, so it doesn't matter if you're in B. Here you're not in B, so it doesn't matter if you're in A. So that's what we mean by and. Oh, yeah, blah, 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 blah. I keep forgetting I have some of this stuff added into there, Let's look like the union. The union is or. And this symbol from set theory, it's just upside down. This one looks like a U, so it makes more sense for union. We use that for or. It's A or B. Another way to look at this is when my wife and I got married. We both had a lot of CDs. That was back in the day when you didn't get all your music online, right? You didn't stream it. You actually bought it. And so I have all these CDs. My wife had all these CDs. We had a lot of CDs between the two of us. When we were joined in wedded union, our CD collections were joined. And if it was in my collection, it was in our collection. If it was in her collection, it was in our collection. That was the union of the two. If we looked at the intersection, that would be, hey, here's a CD that I owned a copy of and she owned a copy of. So we both owned a copy of the same CD. There might have been one when we got married that fit into that category, but not really. We have totally different tastes. But union, intersection, those are the things we're going to be thinking about. Oh yeah, blah, 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 blah. Okay. So let's look at a few of these. So I'm going to use these as my 4 events. So let's clear this off, and to make it a little easier, I'm going to write on the side, A is the jack of diamonds, B is any jack, C is any diamond, and D is a face card. Okay. So if we're looking for not D, D is the face card. We don't want the face cards. So we'd cancel all that. And this would be our event not D. Would be all of those cards. So there's 40 options for not D. Whoops, I didn't want to do that. Let's do that. Let's do this. Let's make this huge. Yeah, this is fun. Whee! Oops. It's going out of control! Okay, I don't know what it's doing right now. I'll blame it on Daphne. I don't know if you heard her purring in the background here. Okay, let's try this again. Okay, that's working better. For B and C, B is all the jacks. Which for some reason, this picture I have represents the jacks with a little 8, it looks like. I have no idea what that's talking about. C is all the diamonds. So we're looking for the event B and C. So we're looking for the intersection. So the intersection is just this one, the jack of diamonds. So B and C also equals event A, by the way. Funky weird. Okay. Let's get rid of that and go to our next example. Now, when I want B or C, B is all the jacks. C is all the diamonds. So we just had that. When we did B and C, we only wanted the jack of diamonds, the way they overlap. But now when we want B or C, any of these work and any of these work. So we got 13, 14, 15, 16 possibilities for the event B or C. Finally, just to refresh this notation, this is the intersection, that's the and. So if we look at C, which is the diamonds, and D, which is the face cards, my intersection is going to be these right here. Those 3 cards are the only ones that are both a diamond and a face card. So that's, again, these are our boolean operations. Boolean actually comes from, is named after a guy by the name of Boole, who did a lot of work with computers and binary math. So with a Boolean operation, you're going to get either a true or a false. You're either It's either true or it's false. You're in the set, you're out of the set. So we use that a lot for searches. It's used a lot with computer work because computers are binary. So if you do a lot with that, you're going to be a little bit more familiar or work more with this idea of boolean operations. Other words we're going to use when we're talking about events is at least, at most, and inclusive. So at least, that's going to be the smallest number. But since it's at least 12, 12 is possible. So you notice I'm greater than or equal to 12. At most is the largest. So 12 is the biggest number. But again, I can equal because it's at most. Inclusive, we talked about inclusive yesterday when we said the values you get from a probability is between 0 and 1 inclusive. Inclusive means we include the endpoints. So if I say x is between 4 and 7, I get this inequality. So 3 or 5, 6 work, 4.5 works, 4 is not in here because it's not between 4 and 7 because 4 is not included. But if we say include it, inclusive, then yeah, we can include 4, we can include 7. So when we talk about, we will watch out for sure when we're saying, I'm looking for something between these two values. Am I inclusive or not? Do I include these values or do I not? Sometimes we'll say this is exclusive. We're excluding the endpoints. Here we're including. So, last thing we want to talk about with these, when we're talking about more events, is something we talk about mutual exclusivity. Or two events are mutually exclusive if no two of them have outcomes in common. As I say, when my wife and I got married, our CD collections were practically mutually exclusive. As I say, this was a long time ago. I think we might have had one in common, which means we actually weren't mutually exclusive, but, So again, coming to Venn diagrams, when we have here two events, this is mutually exclusive. They don't overlap at all. The intersection is nothing. These two overlap, so they have some common outcomes. There's something in common with A and B, so these are not mutually exclusive. If you get to 3 events here, these are mutually exclusive. There's no overlap. These, they all overlap. It's obviously not mutually exclusive. But to be mutually exclusive, there has to be no possible overlap. So even though A and C are mutually exclusive, B and C are mutually exclusive, but A, B, and C are not because there's some overlap. So if you have more than one event going on, if there's any overlap at all, we got to throw out mutually exclusive. That's going to become important when we get a little farther into this section about trying to figure out how big is your sample space. Or not your sample space, how big is your event. So that's a little bit more with events. A lot more, again, this is a lot more vocabulary, a lot more of just kind of picking it apart, not too deep into things yet. So why don't we work on these few pages? Enjoy.